Welcome to the documentation video for my Unreal Engine Marketplace plugin Aim Assist Scripts. This video discusses its features, use, and compatibility so you can decide if the asset is right for your project, and if so, how you can use it. Before we get started though, I would like to mention that the video is intended to promote and document my paid Unreal plugin. Important compatibility information for the plugin. It is a code plugin. The asset uses Unreal Engine's enhanced input in some of its modules as it enables a hassle-free integration. It requires a player controller and for one of the scripts a character movement component. It was tested on a humanoid character in first and third person using a controller and keyboard and mouse, so it was not tested on mobile and on VR. The scripts work on the player camera to rotate it directly or augment the look input. The asset supports multiplayer, but considering that it calculates rotations based on what the player sees, it only works on the local player controller. With that out of the way, let's see the content. The first two aim assists rotate the player controller on their own, which is why they are called rotational aim assists. Magnetism rotates the player controller to compensate for the player's strafing movement. This is useful when you are trying to AD strafe a target, where otherwise you would have to look back and forth to keep track of the target yourself. The script supports mirror or counter strafing by having a different smoothness value until you face the target and after you passed it. These two values are interpolated along a certain percent of the aim assist radius, so the transition between the two is not abrupt. So the settings for it are enable or disable the assist, including its target selector, horizontal smoothness towards the target, the value to set how aggressive the script is when the player moves to the target but does not yet face it. Lower value is stronger. Horizontal smoothness away from the target, the value to set how aggressive the script is when the player has moved past the target. Lower value is stronger. Horizontal smoothness granularity, the percent of the aim assist radius that is used to interpolate between the two smoothness values. Vertical compensation, whether the script should work when the player jumps or drops from high ground. Vertical smoothness, the strength of the aim assist on the vertical axis. Motion tracker automatically tracks the enemy's movement. This is done in a way that the player can still pre-aim and let the enemy walk into the crosshair. This script, same as Magnetism, has two interpolated values that define its aggression, one when the enemy is about to step into the crosshair, and one that is used to drag the crosshair after the enemy. Unlike Magnetism though, Motion Tracker does this along a vertical axis as well, so aiming from high ground tracks the enemy all the same. The settings are enable or disable the script, walk into crosshair multiplier, the multiplier applied to the one-to-one tracking of an enemy while it is about to step into the crosshair. Higher values mean a more aggressive assist. Walk out crosshair multiplier, the multiplier applied to the one-to-one tracking of an enemy while the crosshair tries to follow it. Higher values mean a stronger assist. Multiplier lerp distance, same as Magnetism's granularity, the percent of the aim assist radius along which the two multipliers are interpolated. Disable when strafe directions match. To enable counter strafing, the script doesn't intervene when the player mirrors the enemy movement with their own movement. It should just be left active, but I wanted to have this to be an option. The rest of the aim assists augment the player's look inputs, so they are input modifying aim assists. Aim compensator pretends as if the player was aiming perfectly towards the center of the target and changes the raw look input to gravitate towards the target more. Naturally, the player has to be aiming at the target at least to some degree. This angle is a threshold that is set as a configuration for the script. And of course, its strength can be configured as well, ranging between a minimal nudge towards the mark all the way to basically overriding the player's look input. Its settings are as follows: enable or disable the script, dead zone multiplier, a percent of the reticle's radius starting from its center where the aim assist is not active. Aim angle threshold. The player has to look towards the target within this angle for the script to take effect. Wide angles are more forgiving, while narrow angles require more precision from the player. Strength at edge. The strength of the assist when the script just found the edge of the target. Strength at center. The strength of the assist when the crosshair is on the center of the target. Friction is a fairly simple script that slows down the player's look input when a target is found. To avoid an abrupt change back to the original sensitivity when a target is lost, it gradually removes the assist over time on losing the target. Settings for friction are enable or disable the script, sensitivity multiplier at center, how slow the sensitivity should be when the player looks directly at the target, sensitivity multiplier at edge, how slow the sensitivity should be when the assist has just nicked the edge of the target, time to regain original sensitivity, how long in seconds should it take for the script to remove the slowness from the look input after losing a target. Aim is extremely simple, so much so that it is active regardless of finding a target, so it has no target selector. It is used to avoid an unwanted diagonal aim, and it does this by picking the more dominant look axis and scaling down the other one. So suppose your player wants to look to the right, but the input isn't perfect and would end up looking to the right and slightly a bit up. Aim takes the up component of the input, scales it down, and the end result is a more accurate turn to the right with a minimal look to the up. Its settings are enable or disable the script, and a smoothness multiplier, which is a multiplier applied to the less dominant axis. Be mindful not to make this way too slow, as it may result in a more jagged, staircase-like input. The scripts support having different configurations for different targets. They distinguish targets by their tag and store a configuration struct for each tag in a map. When a target is found, its tag is used as an index to get the config that was set up for the specific target. This way, you have options to establish an aggressive aim assist for fast-moving smaller enemies, and tone down an assist against large and slow enemies. How does target selection work? In a nutshell, the selector shoots spheres forward or lines in a cone shape, and if those find a blocking hit on a component that is tagged as a target, the target selector has found the target. You may use a sphere projector that shoots several progressively smaller spheres forward until it finds a target, or its maximum allowed cast exceeded. Shooting multiple spheres is useful when the target is behind the cover. This, as you would expect, means that the selector is narrow at a distance, but large up close. You can also set a near and far clip distance to define the close and far range of the target selector. You can also use a cone-shaped projector that works closer to a regular reticle. This is done by shooting line traces along rings inside the cone. To pick up smaller targets, you can change the density of the lines inside the cone with the baseline shooting just 5, and higher settings progressively subdividing the cone into multiple rings and shooting traces inside those smaller cones as well. In spite of Unreal Engine handling a large number of line traces pretty well, this can still add up when you also consider the rest of the code for your game, so use a setting as low as you can get away with. When these spheres or lines are blocked by a component, be it a primitive or a physics asset on a mesh, it checks the tags of that component, and if it matches the tag that is set inside the target selector, it has found a target. Settings for the target selector are as follows. Select whether to use spheres or line traces in a cone shape. With spheres, select the maximum sphere cast count that shoots the progressively smaller sphere, and select the radius of the outer sphere. With cones, select the cone angle and the subdivisions of the cone. With either, select the near and the far clip distance. Integrating the plugin into your project. Setting up the player. So first things first, import the plugin. This may import and enable enhanced input as well, as the automatic integrator depends on it. Place the blueprint subclasses of the aim assist scripts on your player controller. For Magnetism and Motion Tracker, make sure that the Auto Apply Aim Assist flag is active. This will automatically add the calculated pitch and yaw adjustments from the scripts to your player controller's rotator. For each aim assist, set up the configuration as you wish, and you also set a tag to look for, which qualifies an actor as a target. For each aim assist, pick how you want the selector to handle collisions. You may use a collision channel, such as visibility, or a collision profile that is defined by you to suit your project's particular needs. Just make sure that you also include the map in some way, otherwise the scripts will track your target through walls. For each aim assist, set the preferred bone, which is a setting that is used on targets that employ a physics asset. Usually, this bone will be the head in case of humanoid characters. What this will do is, the bone's location will be considered the target location in the script's calculations. As for activating the input modifying scripts, you have to add them as an input modifier inside your enhanced input component's look input action. If you need to integrate the rotations yourself, just add the calculated values to your local player controller's pitch and yaw. Make sure to add an unscaled value, as the calculations are exact and unscaled. Adding the input modifying scripts manually requires getting the scripts integrator that the modifier instantiates behind the scenes and running the raw input through it before use. Moving on to setting up the enemy. You may use a collision primitive that is added to your target's head and torso, for example, and tag it so the aim assist knows that you intend this piece to be a target. When you set up a collision profile or channel for the target, know that the target selector shoots blocking spheres or lines, instead of overlapping ones. You may also use a physics asset on your enemy character's mesh, in which case make sure that there is a bone with the name as the aim assist script's preferred bone. In this case, you will tag the mesh component of the actor. Afterwards, you can set up the collision data as before. Lastly, a couple of words about the practice range that comes with the plugin. The practice range serves as a reference for you to tweak the aim assist settings to suit your project the best. It is equipped with an emitter that shoots projectiles, a standing still target, a regular AD strafing target, a simple grid shot that doesn't track the player scores, vendoring AI targets, a randomly AD strafing and crowd spamming target, one that follows the player in a tight small maze, and two targets standing behind cover next to a high ground. Each script is configurable runtime using the overlay, which is also through hitting P on your keyboard, selecting your aim assist on the right, and changing its settings on the left. Exit the overlay by clicking the red box on the top right side of the screen. Thanks for your attention and good luck on your projects.